we see our garage door arrangement. So this is the name, and it has 1, 2, 3, 4, 5 logical label finite state machines. So we have an ATL transformation. USNB as an extension, we don't have a file of this kind. However, if I run a transformation for garage door example, then if I go back here, we see the garage door, and if I run USNB on it, you're going to see that some properties are identified as true. These are properties that check the scheduler. If I actually look at this file, at the end, the properties here were verified. In particular, that we run USNB interactively. I have a file, then we can pick a state. We can actually simulate 700 states on the model checker, and as you can see, there's too many states, so we can actually provide the 5 sensors. We have moved a bit in the progression. The turn is of the first machine. Put the same values of the sensors. Now we have moved to the next finite state machine, and we're building a trace. I could keep on doing this. I have a file. We have the initial commands, and then we are interacting with USNBs. And you can see that for a while we are saying that the remote control is indicating idle. Then for a while we're gonna actually indicate open. Then later on we indicate idle again. And later on we're gonna indicate backward. This is gonna be our input file. Produce a trace. Check what is the process. Kill it this way. Actually, you get to see here the interaction session, but if I go all the way to the end of the file, as you can see, it has 96 script states. I open trace, find trace description, find it again. I'm going to delete everything at the top of this file, and then I'll use it as an input to our GUI for trace emulation application that I have here, so that we use the EMF classes to emulate the model checker. Let's run this application. I can open the model of the garage door, which is an XMI model. I'm going to also open the recent generated trace. I have the machines here and the environment. I can expand a bit of view of one of these. We're going to do a bit of space here. The very first state of the trace, that is the turn for the first machine. You can see the second machine, the third machine, the fourth machine, the fifth. We have to make this a bit bigger for the timer to show up. We have the timers here, 3 timers. Timer is not going to participate because I want to make the simulation as fast as possible. The first machine is about to fire, so this is a transition and it's in red. So the next script state in the is now the turn of the next machine. So that one is also about to fire. That machine moved its corresponding state. The next one is the actual door controller, and it's also about to fire. And we can see what things get updated. The remote control. The motor also goes from the DOM initial state to its initial state. The timers don't really do anything. They're going to stay actually in their initial state. So we're back to the sensor whether the door is open. This turn is going to have no effect. We go to the closed sensor, and in this case we are in the situation where the door is closed. These logically will find the state machine, is going to fire this transition. The sensor is going to indicate now in its status that the door is closed. We see how it is. The controller is not receiving any signals from the remote control at the moment, so nothing is happening there. The motor is not moving. We just go very quickly through the timers and we're back to whether the door is opened. Now we have that the remote control is sending the signal to open. The door whose closed is not doing anything. The remote control itself has to change state and is going to indicate that we want to open. The turn belongs to the motor. We continue. As I mentioned, the timers won't participate. We won't stop the door halfway. Now the door controller receives the signal from the remote control. It's going to indicate to the motor to move. The remote control remains in its state. The motor receives a signal to go forward. Nothing for the timers. The door is not opened, but now the door is no longer closed. The sensor here changes the state. The remote control now is released, so it's going to go back to idle, and the motor is still opening the door. Now the fact that the remote control is idle is recorded by the door controller. There's no change in the remote control. The motor, as you can see here, that turns. Now, yes, we have fully opened the door. Door open is press. That changes the state. The door controller will change to the state of fully open, and it will indicate to the motor, send a signal to stop. So now the state machine of the motor will change from moving forward to stopping. The door is fully open. Now the remote control backwards. First have an effect here. Signal that the remote control is sending. It's sending the signal close. We see here in the door controller takes it to the state in which the motor now is going to move backwards. The motor receives the signal, goes backwards, so it starts to close the door. Obviously the sensor that the door is open changes state. Just need to keep on going until the door is closed. Now the door is closed because the sensor gets pressed, so the sensor changes its status. Therefore, the door controller is going to fire to the state that it signals a stop to the motor. The motor has stopped.